This is problem number 5 from section 310. In this problem it says sand falls from a conveyor belt at a rate of 11 meters cubed per minute. By the way, that's a meters cubed, that's a volume. Onto the top of a conical pile. The height of the pile is always 3/8 of the base diameter. How fast are the height and the radius changing when the pile is 4 meters high? Let's start by writing down this volume equation. It says it's a cone, so we're going to say the volume equation. You might have to look this up, but it's V equals pi r squared h over 3. So we got radius and we got a height. And they're asking us how fast are the height and the radius changing. So we want to know d of h over dt. We also want to know dr over dt. So we got two things we're looking for there. They give us a little piece of information. They say the height of the pile is always 3/8 of the base diameter. So the height is equal to 3/8 of the base diameter. Well, the base diameter is r squared. Not r squared, 2r, because we've got, diameter d is going to be just the radius plus the radius. So this is actually, we're going to cross that out. H equals 3/8 times 2r, which is equal to 6/8 r, which is equal to 3 over 4r. So the height is 3 over 4r. Now that's an important piece of information because we have this volume equation with 3 different variables. We got v, we got r, we got h. We'd like to get it down to 2 variables. And so we're going to take, in my opinion, I think we should take, what do they want us to find first? They want us to find how fast are the height and radius changing. So it doesn't really matter how we approach the problem. We're going to end up having to plug this in for h, and then we'll have to solve this equation for r, and then plug in r for h there. So no matter how we shake it, it's going to be a long process. So let's take 3 over 4r and plug it in to start. So we have v equals pi r squared, and then we'll plug in 3 over 4 r over 3. And you know, we might as well just rearrange this. So if we rearrange this, we end up with multiply by the reciprocal 4/3, and we'll end up with 4/3 h equals r. And let's write the second part. So this is part 1, and this is part 2. And this is, we're trying to find in this part dr over d. We're going to write this here. This is dr over dt, and this will be dh over dt. So we're going to take that and plug it into this equation for r. So we end up with v equals pi, plug 4/3 h in, squared h over 3. So I think we're set up and ready to go. Let's just start and focus on this one side now and find dr over dt. So we got to do some multiplying here first. So v equals, when we multiply this through, first of all, the 3 over 4 divided by 3, well, that's going to be 3 over 12, which is 1/4. Essentially, the 3's cancel, and we end up with 1/4 pi r cubed. Now we're going to do the derivative with respect to time of the volume equation. And when we do the derivative here, we're going to end up with dv over dt equals, this will be derivative on this side. We'll bring the 3 to the front, so we end up with 3 over 4 pi r squared dr over dt. So now we want to figure out what was, let's see, they told us the dv over dt. I guess I never wrote that down. dv over dt. They gave us, at the beginning, they gave us 11 meters cubed per minute. Do we know the radius? It says how fast are the height and the radius changing when the pile is 4 meters high? So they give us the height. Can we find the radius from that? Well, we can right here, because if the height is 4, Let's plug 4 into this. We end up with 4/3 times 4, which is the radius. So 16 over 3 is the radius. And that's 16 meters over 3. So we're going to plug all this in, and we're going to say that we have 3 over 4 pi. This is 11 meters cubed per minute. This is 3 over 4 pi. We're going to multiply by 16 meters, so 16/3 meters squared. And we want to find dr over dt. So we're going to solve for dr over dt here. Well, let's go ahead and move everything to the other side. So essentially what we're going to do is we're going to get 11. Well, we can do all this at the same time. We're going to multiply by 4/3. Well, let's just divide this whole piece. That'll be easiest. We're putting it in the calculator anyways. So we have 11 meters cubed per minute, all divided by 3 over 4 pi 16 over 3 meters squared. That's what dr over dt is. Now when we divide this, we end up with let's see here. We're going to end up with this in meters, so let's see. We'll end up with let me pull out a calculator so I can do some pies. So we're going to take 3 over 4.75 times pi and we're taking that times 16 over 3 squared. So we'll say 16 divided by 3 squared. And then we need to take 11 divided by this number, so we'll take divided by 67.02. And we basically end up with 0.1641. This is a radius, so this is a meters per minute. But I think in your problem, they're going to ask you for centimeters per minute. So essentially, you just need to move the decimal place 2 over to the right. So it's 16.41 centimeters per minute. Okay. Now we're going to do the other piece of this problem, which is the height. We want to find dh over dt. So we're going to say v equals 4/3 squared. So we end up with pi times, this will be 16 over 9 h squared times h over 3. So we end up with v equals, this will be, when we multiply this, we get pi times 16h over 27 meters squared. So now we can go ahead and, no, that's h squared. So this is h cubed. Can't even read my own handwriting. So h cubed. H squared times h is h cubed. I'm going to rewrite this. Shout out to Sophia. So 16 over 27, this is h cubed. So bad. So now we're going to actually do the derivative of this. V equals pi 16 over 27 h cubed. So when we do this, we end up with dv over dt which is equal to, this will be, we're going to have 16 pi. We're going to have, bring the 3 out front, so we're going to end up with 3 times 16 pi over 27 h squared dh over dt. So now we're going to plug all our numbers in again. So we end up with 11. And I'm going to save the labels. We know it's going to end up being centimeters per minute. So we're going to just say 11 equals 3 times 16 pi over 27 h, which we know h is 4 meters, so we have 4 squared dh over dt. Divide this over and you get dh over dt is going to equal 11 divided by 3 times 16 pi over 27 times 16, and that's going to end up being, throw out the calculator, 0.1231. So then this will be meters per minute. We need to convert that to 12.31 centimeters per minute. That's what they're going to ask you for in your problem. So the rate of change for the radius is 16.41 centimeters per minute. So the bottom of the sand pile is changing at 16.41 centimeters per minute, and the height is changing at 12.31 centimeters per minute.